Problem number 27 is asking us to evaluate this integral using change of variables. This is the integral over this region here. Let's sketch out what this region looks like. Okay, x runs from 0 to 2. We also see that we're going to need the line y is equal to negative x over 2. So this is y is equal to negative x over 2. And then we are also going to need y is equal to 1 minus x. And I think that should be y is equal to 1 minus x. Okay, so it looks like we have a triangle here with vertices 0, 0, and 0, 1, and 1, 2, comma, negative 1. Okay, so we were told what change of variables to use. Problem author was generous, said use x is equal to 2u and y is equal to v minus u. Okay, so let's figure out what that's going to be bound-wise here. X is equal to 2u, so 2u is between 0 and 2, which is, hey, that's u is between 0 and 1. And then y, v minus u, is going to be between negative x over 2. So negative x over 2 is, well, x is 2u, negative 2u over 2, to 1 minus x, 1 minus 2u. So let's see here, negative u less than or equal to v minus u less than or equal to 1 minus 2u. If we add u everywhere, we get v is between 0 and 1 minus u. So in the uv plane, let's sketch this. We aren't asked to do this, but I think it's useful here. U runs from 0 to 1, and then v runs from 0 to 1 minus u. Will be, this is the curve, v is equal to 1 minus u here. And so we'll be integrating over this triangle right here. It's worth checking just to make sure that all of the corners of the triangle are center corners of the triangle down here. 0, 0, if you plug in, if you, well, let us figure out here. Yeah, okay, so I guess part A did ask us to do R and S here. We found the limits of integration for the new integral. U is from 0 to 1. V is from 1 minus u to u here. Okay, so what else do we need to do? We need the Jacobian here. So the Jacobian of our transformation, I'll call the transformation G here, is going to be following matrix of partial derivatives. It's going to be partial derivative of x with respect to u. I shouldn't say matrix, I should say determinant. Partial derivative x with respect to v. Partial derivative y with respect to u. Partial derivative y with respect to v. And so those partial derivatives are going to be 2 and 0, and then negative 1 and 1, and this determinant ends up being 2. So we'll throw in a factor of 2 here. Okay, so by the way, I guess I started to make a point and then stopped making it. Let me make the following point a little bit more thoroughly. So let's just think about, you know, x and y are written in terms of u and v. Let's go from here to here. Okay, if u and v are both 0, x and y are both 0, so this point gets sent to this point. If u is 0 and v is 1, x is 2 times 0, 0, y is 1 minus 0 is 1. And then if u is 1 and v is 0, x becomes 2 times 1 is 2, y becomes 0 minus 1 is negative 1. So that gets sent there. So this is all kind of checking out. Okay, so change of variables time. Change of variables, we know that, let's see here, our bounds are u runs from 0 to 1. V runs from 0 to 1 minus u. I'm using that right here. We know we're going to have the Jacobian factor is 2. It's absolute value of 2, but it's positive here. 2v dv du. Okay, what's left here? X squared, well, x is 2u. So 2u quantity squared. And then square root of x is 2u plus 2 times v minus u. And so we end up with here 0, 1, 0, 1 minus u, 4u squared. And then this right here, we see that a 2u and a negative 2u, those will cancel, times the square root of 2v. Times 2, so this is going to be 2 times square root 2 times v to the 1/2 power dv du. Okay, I'm going to stop evaluating this in the interest of time here. This is a pretty straightforward integral to evaluate at this point.